Alright, in this video we're going to go over Newton's method. Now, Newton's method is a method for approximating a root for a function. So we're going to use this formula. It says xi plus 1 equals xi minus f of xi over f prime of xi. Now, our function is f of x equals x squared minus 5. And our first initial guess, which is x sub 1, is 2. To start this problem, we're going to just plug in our variables. So, xi was 2, and the function was 2 squared minus 5. Plugging in 2 for x. And this is over the derivative of the function, which was just 2x, and x was 2. Now we just solve this problem, and we get 2 minus 1 over 4, plus, alright, plus 1 over 4, which equals 9/4. And this 9/4 is our x2. Now we're going to plug it back into the function, which is xi plus 1, or in this case, x3, because this is our third guess. And we're going to have 9/4 minus x squared minus 5 over 2x. Now we're going to plug in the 9/4 for the x's, and we will get 9/4, I don't know how I just zoomed it, 9/4 minus 81/16 minus 5 over 18/4. This is 9/4 minus 1/16 over 18/4. And this in turn gives us 1/32. So x3 equals 1/32. The reason we use Newton's method is, say we have a graph and we have a function, and we're trying to find the zeros for that function. We can pick points close to the zero on the graph and find the derivative at that. At that point. Now this derivative will hit on the x-axis close to the root. If we keep picking numbers closer and closer to the root, the tangent line will get closer to the root. And we will eventually be very, very close to it. Once again, the formula for Newton's method is xi plus 1 equals xi minus f of xi over f prime of xi. The I is your initial. Your next guess is why the plus 1 is here. So if you have x of 1 plus 1, that'll be your x2. And you just keep going, and we usually stop around x3, but you can keep going after that to get closer and closer to the 0.